All right, hi there, everybody. In this video for Professor Carbon, what we're going to do is go over some of the basic reactivity of amines, especially when given multiple different nitrogens in the same complicated molecular setting. And so what we have here are three fairly complicated molecules, all of which have more than one nitrogen atom in them. And what we're going to be is tasked with trying to come up with the most basic nitrogen atom. And we're going to rank the most basic nitrogen as 1, and then we're going to try to rank the least basic nitrogen as 3. And as we know from class or your chapter on amines, the basicity of a nitrogen atom is very dependent on what kind of functional group it's part of. So let's take a quick gander through the first molecule here. We can see that we have 1 nitrogen, 2 nitrogens, and 3 nitrogen atoms. Okay, and so what I'm going to do is name all of these depending on what functional group. So this one is going to be part of an amide. This one is going to be a nitrile. And then over here we have a true amine. And the way I know that it's a true amine is there's an sp3 carbon atom over here and an sp3 carbon atom on the other side as well. And so that indicates to me that that nitrogen is truly in control of its full lone pair. It's not delocalized into any other functional group. So for instance here, that nitrogen lone pair is partially delocalized into the carbonyl oxygen. All right, and so our alkyl amines are definitely the most basic. So number 1 is going to be the most basic of these groups. Then we have a little bit tougher choice between the amide and the nitrile. And, you know, this gets into a little bit of how the question is subtly phrased. I generally consider amides to be a more basic functional group than a nitrile. That being said, it's a little bit ambiguous because it says specifically the nitrogen atom in the amide. And the nitrogen atom is not where most amides protonate. And so because we have this resonance structure, if you protonate most amides, they will protonate on the oxygen, not on the nitrogen. And so at least technically as written, the nitrogen atom is not basic at all. The oxygen atom is the basic atom in an amide. And so we can kind of default put number 2 down here at the end. And so that means 3 goes in the middle. So that should hopefully help us out with the first one. The second molecule here also has a number of nitrogens. So let's just circle those. We've got 1 and 2 and then 3 down here. And again, you know, if we look at nitrogen 1, we can notice that it's sp3 over here. It's sp3 on that side and sp3 on that side. And so this is a tertiary nitrogen, and it is surrounded by alkyl groups. And so again, that'll for sure be our most basic. So most basic group there. Now we have a choice between 2 and 3. Again, nitrogen 3 is part of this amide group. And not only that, this nitrogen lone pair, I'm going to choose a different color there. The nitrogen lone pair is also delocalized into the benzene ring and the rest of the aromatic heterocycle. And so the nitrogen in 3 is going to be the least basic. And so again, then number 2 goes in the middle. And I'll point out that nitrogen 2 is sp3 hybridized on this side and sp3 hybridized on that side, but it's sp2 hybridized over here. And so what that means is that the aniline, which is the special name that we give an amine coming off of a benzene, remember that lone pair can delocalize into the benzene ring. And because of that, that nitrogen is less basic than the standard nitrogen next door. Okay, and so this is reflected in the pKa's. So anilinium, that is the protonated form of aniline, has a pK of about 5.5, whereas the protonated form of triethylamine or triethylammonium has a pK of maybe 11. And so that difference of about 6 pK units in rough terms is about how much less basic the aniline nitrogen is versus a regular tertiary nitrogen. All right, over here we have some of the same problems, and so hopefully you're getting the pattern down at this point. So for the nitrogen 3, again, we can recognize it's part of an amide this way, but this one's actually doubly an amide, if you will. And so that nitrogen lone pair is going to be pulled in both directions. So we don't even really have to look a whole lot further. We know that that one's going to be even less basic than the amides that we talked about up above. Nitrogen 2 here again is going to be sp3, sp3, and sp3, and so that's going to be our alkyl amide or nitrogen atom, a truly basic nitrogen, a tertiary amine, and so that one's going to be our most basic. And so again, then we can put number 1 in the middle. And you'll notice now again, same trend as before, sp3, sp3, and now it's sp2. And much like our amide, this same kind of substructure here lets that nitrogen donate its lone pair all the way up into the other nitrogen atom that I'm circling right now. But because nitrogen is less electronegative than oxygen, that effect isn't quite as strong as it is in the amides. Regardless, it's an easy choice to make because this one has one heteroatom that it could donate the lone pair into, and the nitrogen over here has two different oxygens. All right, and so what I'm hoping that you'll get out of this video is being able to go through and recognize the difference between nitrogens that are part of an amide versus nitrogens that are truly basic alkyl amines. And the easiest way to tell that is to look at not the nitrogen, but what's next door to the nitrogen. All right, thank you for tuning in to Professor Carbon. I hope you'll like and subscribe to our YouTube channel. Also, please follow us on Twitter or Facebook. We appreciate the support. And please go ahead and watch another video. As a brief reminder, these are all color-coded by the functional group and also kind of the problem that we're going to be talking about in the video. And so hopefully you can find the content that you're the most interested in simply by paying attention to how the thumbnail slide is color-coded. Thanks, and come on back.